Okay, so as I mentioned, internal energy is a type of state function, and the book defines state function. It says a state function's value depends on the state of the function and not how it arrived at the state. Now, I know what a state function is, and when I read that, I have a hard time understanding what a state function is. So try this on for size, right? It is what it is. So what does that mean? It is what it is, right? You say this all the time. Something happens. Well, it is what it is, right? That's just the way it is. And the reason we say that is because it doesn't matter on the history of that particular item. That's just what it is. Doesn't matter how it got there. That's just what the value is. And so another way to think of a state function is that it is the value of a function, right? It's just what it is, independent, and it's independent of the function's history, like what was done. So it is what it is defines a state function. It's not important what the history of the object is, it's just what the object is, okay? So it's just what the value is. So what kind of things are state functions? Well, if you think about these two pathways, path A and path B, people are walking on path A are going to walk a lot further, right? Because this pathway starts down at the bottom, goes like this. Oh, I went off the trail. I know some of you will do that too. That's a much longer trail. Path B, right? How far you walk, in other words, is not a state function. How far you walk to get from here, this altitude, to this altitude, right, depends on the path you took. So really it depends on the history from how you got from the bottom to the top. But the altitude is a state function. You're going from 0 feet, in this case, to 10,000 feet, as he talks about in his book, right, in Tro's book. Regardless of how you went up the hill, your change in altitude will always be the same. And so it is what it is. When you're start at the bottom at 0 feet and you go to 10,000 feet, you just went 10,000 feet. That's all that it means, okay? Okay, so the delta in a state function is always the final state minus the initial state. So for altitude, let's just call it A, right? And let's say you start at your initial state was at 0 altitude, and your altitude final was 10,000 feet. Then delta A is A final minus A initial. Sorry, sometimes called A0. And that's just going to be 10,000 feet. On the other hand, when you're coming back home, assuming you made it all the way to the top, then your A initial, when you're starting here, an A initial is 10,000 feet, sorry, and then A final is 0 feet. So delta A, the change in A, will be A final, which was 0 minus 10,000 feet. That's minus 10,000 feet, which means you went down 10,000 feet. The negative is just the direction in which you're traveling, whether or not altitude was gained, or in the case of coming down, altitude was lost.